All right, perfect. So now let's continue. So we figured out how the cryptographic transactions work, but we assume the trusted ledger, and a trusted ledger owner. And that's something that cryptocurrencies don't want to assume, right? They don't want to trust any one entity. So we have to find a way to implement this ledger. So this ledger has two pieces in Bitcoin, something called a hash chain, or what is technically the blockchain. And the second one is consensus, a way to achieve consensus between different people in the world as to what is the current state of the blockchain. And that's done via a tool called proof of work. So in this class, we're going to explain the hash chain and blockchain. And then in the next lecture, we'll go to consensus via proof of work. And we'll also see some, the blockchain live and see a demo as well. Okay, but so far, let's focus on the hash chain or blockchain. So the blockchain is basically a chain of transactions using their hashes. So it's a hash chain. In fact, in cryptography, we had these hash chains for a long time. And so the notion of a blockchain wasn't quite new to us, but the way it was used, it was new in Bitcoin. So the idea is that each transaction contains the hash of the previous transaction, which contains the hash of its own previous transaction, and so on. So if I look at the current transaction that has a hash of the previous one, which has a hash of the previous one, and so forth, essentially in the current transaction, I have a whole history of what happened before in that hash, right? Because why? That hash contains the hash of the previous one, which contains the hash of the previous one, and so forth. So that's why it's very powerful, because in one hash, you essentially capture the whole history. So let's look here in a bit more detail. So I have block 1, the initial budgets, block 2 was transaction 1, and block 3 was transaction 2, and I remove some details here. So in this transaction, I'm also going to include the hash of this second block, the whole block 2. Okay, I'm going to take the whole block 2, I'm going to get the X1, I'm going to get the signature, I'm going to include everything in this block 2, and I'm going to hash it and include it in the transaction 2 statement. So when I sign transaction 2, I'm basically indirectly also assigning this block 2. Okay? And the same here in transaction 1, I had the hash of block 1. Okay? This block 1 was the initial, also called Genesis block, so it doesn't have any previous block, but all the others have a previous block. So notice very interestingly that this hash of block 2 contains this hash of the whole block 2, which includes the hash of block 1. Okay, but the hash of block 1 is the hash of this. So basically in this one hash, I included the whole history. All right. What are the properties? Well, a very important property is the following. Let's assume someone gave you the hash of block I from a trusted source. We'll see later that it comes from the consensus, but for now, just assume it's from a trusted source. Okay, we're building one step at a time. So assume that somebody gave you the hash of block I from a trusted source, but then you download blocks 1 through I from someone you don't trust. Okay, the point is that a user, Alice, can verify that blocks 1 through I are not compromised using hash of block I. Can people tell me how? So can people tell me how can Alice verify that some blocks 1 through I received from an untrusted source are actually correct, or detect if they're not correct, given that the only thing that Alice has is the hash of block I? Vikram?
Could you hash 1 and then get block 2 by hashing 1, then block 3 by hashing 2, and do that until you reach I, and then compare it to hash of block I and see if they're equal?
Exactly. That's what you're going to do. Exactly. So Alice is going to start from block 1, hash block 1, then is going to compare to that hash into block 2. If it's fine, then it's fine. Then it's going to hash block 2, compare to that hash in block 3. If it's fine, then it's fine. It's going to hash block 3 and compare to the hash in block 4, and so forth, all the way to the hash of block I, which is received from a trusted source. If they match, then the blocks 1 through I are correct. Otherwise, they are not correct. Okay? So Alice recomputes the hashes of each block, and it checks that it matches the hash in the next block, and so on, until the last block, which she checks against the hash from the trusted source.